Simplify the following rational expression. X plus 3 squared times x squared is 10x plus 25 to the fourth all over x squared plus 8x plus 15 to the sixth power. Now, before you start actually foiling all of these out or multiplying all of these out, there's a trick to actually being able to do this. So notice first that x squared plus 10x plus 25 is a perfect squared trinomial, right? And it factors into x plus 5 times x plus 5, which is otherwise known as x plus 5 squared. And also notice in the denominator, x squared plus 8x plus 15 factors into x plus 5 times x plus 3. So now using these substitutions where you substitute this for this and this for this, we can rewrite up the above like so. So we get x plus 3 squared, that doesn't change. And then here, x squared plus 10x plus 25 is x plus 5 squared. But we're taking all of that to the fourth power, right? Let me move up a little bit so we can recall. And then in the denominator, x squared plus 8x plus 15 factors into x plus 5 times x plus 3, and that's all taken to the sixth power. Okay? So now what we do is to simplify by using the laws of exponents. So for x plus 5 squared taken to the fourth power, we can recall the law of exponents rule that, let me do that on the side here. The law of exponents rule that says that if you take a power and then you take it to another power, you multiply those exponents, right? So this is going to be a to the r times s. So you can think of this in the exact same way. So this becomes x plus 3 squared times x plus 5, and then 2 times 4, you multiply 2 and 4 to get 8. And then in the denominator, you can think of the rule where you have a times b to a power. What happens? Over the product, that power, that exponent distributes. So you have a to the r times b to the r. So the denominator you can rewrite as x plus 3 to the 6 and x plus 5 to the 6. So finally, notice that there's an x plus 3 to different powers in the numerator and the denominator, and the same thing with an x plus 5. So the final rule we can use is that if you have a number taken to a power over a number taken to a different power, what you do in this case, it's the opposite of the multiplying, which means that you subtract the exponents here instead of add them. So now, given that, what we want to do is rewrite this as x plus 3 to the, subtract the exponents, that's 2 minus 6, times x plus 5 to the 8 minus 6. So finally, this becomes x plus 3 to the negative 4 times x plus 5 squared. And then since generally we don't like writing negative exponents, what we do is we take the reciprocal of x plus 3 to the fourth power, and then that'll make the negative go away, right? Because that's the last rule of exponents we need, is if you have any number taken to a negative power, all that negative does is it gives you the reciprocal. So what this turns up being finally is, in the denominator we're going to get x plus 3 to the fourth, and then in the numerator we just have that x plus 5 squared. And since there's nothing else we can do to simplify, this is our final result.